Hello my dear student, welcome you here in this lecture number 45 for that topic Haloalkanes and Haloarenes. Now we have already studied all the reactions of haloalkanes in the earlier videos. You may check that we have seen different nucleophilic substitution reactions, then we have seen the elimination reaction, then we have studied the part of that reaction with active metals like magnesium as well as with the sodium. Okay, so all that reactions are very important, and directly the questions may be asked how that, suppose bromoethane reacts with so and so, like that in the subjective paper, or MCQs may also be asked. Now we have to learn very important article from this topic on which the long answer type questions can also be asked, and so many MCQs can be framed. And that is the types of nucleophilic substitution reaction that I have written there. Types of nucleophilic substitution reaction, we are going to learn two types. Number one is the SN2 and number two is the SN1. Okay. Now you know about what is meant by nucleophilic substitution reaction. That whenever the haloalkane like RX reacts with Y minus type of the group. What is Y minus? Any group or atom, group of atoms or atom having excessive negative charge or excessive lone pair of electrons is known as what? Nucleophile. A negatively charged group having negative charge or excessive lone pair of electrons is known as nucleophile. That is Y minus. And Rx is haloalkane. So we see that this X minus is nucleophile there. So X minus will be replaced by Y minus. And you will be getting the product Ry plus X minus. Okay. So this is the product. So one nucleophile replaces the other nucleophile. X minus is also nucleophile. That type of reaction is called as substitution nucleophilic. Okay. When a nucleophile is replaced by another nucleophile, a negatively charged group is replaced by another negatively charged group, then that reaction is called as SN reaction or nucleophilic substitution. Now there are two types I told you. One is the SN2, other is the SN1. So let us learn one by one all that two types there. Okay. First of all, we will go to that particularly SN2 reaction. Okay. SN2 we shall learn in the latter part. Okay. Now what is meant by SN2 reaction? So with the help of mechanism that we can prove it is SN2 reaction. Okay. That is, it is called nucleophilic substitution of second order. Nucleophilic substitution of second order. That we are going to learn the order of reaction in the topic chemical kinetics. First order, second order. So why it is called second order, I will tell you. Or that is also known as bimolecular nucleophilic substitution reaction. Bimolecular nucleophilic substitution reaction. Okay. Now why it is so called, that also I will explain you. One by one we will learn. Okay. First of all, we shall have its NEET reaction or example. What is the example of this that we shall learn? Okay. The example of this reaction is alkaline hydrolysis. Alkaline hydrolysis of bromomethane, or that is known as methyl bromide. Now alkaline hydrolysis means what? Means the reaction with aqueous KOH. या aqueous alkali. Alkali होगा KOH, alkali होगा NaOH, like that. Any we can take, or simply OH minus. Okay. So alkaline hydrolysis of bromomethane. Let us write the reaction. You know it better. That CH3Br net reaction plus OH minus. So you may take that from that particularly KOH or NaOH. You better understand. Okay. Now what happened there? When it is heated, you will get the product CH3OH plus Br minus. Okay. Now this is known as methanol. That you know, poisonous alcohol. And this is bromomethane. This is a net reaction I am showing. And this is alkali. Masakali. Okay, this is alkali. And so one nucleophile is replaced by another nucleophile. Definitely it is called as what? SN reaction. So since one nucleophile is replaced by another nucleophile, it will be known as SN reaction. Okay. Now why it is called SN2? That we shall learn in the kinetics. Kinetics of reaction. Number B. It has been observed that a rate of reaction is directly proportional to the active mass or concentration of both the reactants. Which are that both the reactants? Methyl bromide, that is bromomethane, as well as OH minus. Okay. So rate of reaction can be given as K into active mass. K is the constant, velocity constant, we know. Active mass of CH3Br into active mass of OH minus. अभी हमें मालूम है मास लॉ एक्शन वगैरह हम जब लर्न करते हैं, ये एक्टिव मास का मतलब कॉन्सेंट्रेशन, दैट मोल नंबर ऑफ मोल्स प्रेजेंट पर लीटर. सो व्हाट इज द कॉन्सेंट्रेशन ऑफ CH3Br एंड व्हाट इज द कॉन्सेंट्रेशन ऑफ OH माइनस, उसके ऊपर ये रेट डिपेंडेंट है. ओके. जितना दोनों का कॉन्सेंट्रेशन ज्यादा होगा उतना इसका रिएक्शन का रेट ज्यादा होगा. जैसे हमारा क्लास का रिजल्ट रहता है, that I say that it depends upon both the factors, the efforts of teacher as well as the efforts of student. दोनों भी जितने ज्यादा होंगे उतना rate of that success of that batch will be more. मान लो that teacher has taken tremendous efforts there, has covered all articles very properly, has given that sufficient practice, but student has not prepared. उसका concentration यानी उसका preparation का concentration less है, result will be less. या vice versa. Students are very enthusiastic, hardworking, but teachers are not completing their syllabus properly, then definitely the rate will be lower. पर दोनों का अगर combination अच्छा होता है जैसा हमारा हो रहा है, then what happens there? Then the rate of that success will be maximum. Okay. So since rate is depending on two factors, rate depends on concentration of both reactants, two reactants. It is called second order reaction. That's why it is called as what? Second order reaction. Okay, that is called as second order reaction or SN2 बोलते हैं उसे, SN2. Very simple. And why it is called as bimolecular? Bimolecular का मतलब because two molecules are taking part in the reaction. ये दो molecules जो है वो reaction में part लेते हैं, and that's why it is known as what? Bimolecular reaction. जब slowest part आता है reaction का, in that slowest part both the molecules are playing the role, and that's why it is called as bimolecular. तो ये अच्छी तरह से जान लो. Now how it is bimolecular and how the exact details of the reaction are there, that we have to learn in the mechanism of the reaction. अब इसके बाद तीसरा जो पार्ट है वो क्या है? मैकेनिज्म वाला. मैकेनिज्म ऑफ रिएक्शन. मैकेनिज्म के बारे में मैंने आपको बताया था. दैट मैकेनिज्म मीन्स द डिटेल्ड स्टडी, स्टेप बाय स्टेप. अभी यहाँ पे हम डायरेक्टली बता रहे हैं आपको, that bromomethane is acted by OH minus alkali, and then we are getting what? We are getting methanol, and that Br minus is coming out. One nucleophile replaced by another nucleophile. That is called as SN reaction. Okay, पर ये reaction exactly होती कैसी है? How the CBr bond breaks, how the OH minus ion is attacking there. So all that details will be learned in the mechanism of reaction. Okay, पर ये तब तक ये पॉइंट्स डेफिनेटली अच्छी तरह से ग्रास्प कर लो. एक तो पहले मैंने अभी जो आपको बताया व्हाट इज न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन, उसके बाद में उसके दो टाइप्स, उसके दो अलग अलग नाम, उसका एब्रीविएशन SN2. अब इसे SN2 क्यों कहा ये भी मैंने बता दिया, बिकॉज रेट ऑफ रिएक्शन इज डिपेंडिंग अपॉन द एक्टिव मास और मोलर कॉन्सेंट्रेशन ऑफ टू रिएक्टेंट्स. अगर एक ही रिएक्टेंट पे है तो SN1 कहते हैं. ओके, सो आई होप यू हैव अंडरस्टूड ऑल दिस पार्ट. ये बहुत ही इंपॉर्टेंट आर्टिकल है, ये पूरा नहीं हुआ है अभी. You will have to watch my next video to learn the mechanism and how two molecules are taking part in the slowest part. That also we will see there. So soon we shall meet in our next lecture, that is lecture number 46. Okay, thanks a lot.